All right, we're looking at transformations. So we have all of this information given to you. You should be reading slides 5, 6, and 7 and know those slides. 5 and 6, just know the general shape and the look of the function. All right, so that's 5 and 6. 7, you got to know all the transformations that can be made. All right, so we have all this information here that you should have in front of you that you should be reading. I'm not going to go ahead and read all of it and go through all of it. I'm going to apply this to our function families that we have. So all I want to do is describe the transformations. I want to describe the transformations and see what we got from here. So first of all, this is a cubic function. All right, not that I'm going to be asking you from time to time, but we should be knowing that this is a cubic function. From here, we have our a value, we have our h value, and our k value. Our a value is bigger than 1, so it's a vertical stretch. All right, so it's a vertical stretch, and I'm just going to abbreviate it. I'll write it out for you. So it's a vertical stretch, and then technically by a factor of 3. Inside parentheses, we have x minus 4. We're actually moving right 4. And then minus 2 outside, it tells us down 2. So we have that. Next one. We have a negative out front. We flip. So this one's technically an exponential function. Let me write that. So this is an exponential to start us out. There's a flip. The 1/2 tells us that this is a compression, a vertical compression. You don't need to write the word vertical, just tell me it's a compression. Now, this is exponential. This 10 does nothing. This is the a value. This is your h, and then your k would be hanging out at the bottom. Remember, the h has to be inside something, inside parentheses, absolute value bars, exponents like we have here, and we're moving left 5. So we have that. Next one. We got 2 more on this slide, and we're going to look at some graphs. We have an absolute value function, hence the absolute value bars. We have a flip again, no stretch or compression on this one. We're moving up 7. That's it. That's all we got. Left and right needs to be inside something. So it would have had to have been inside the absolute value bars. Last one, we have a quadratic. We have a flip again, threw a lot of flips in there. This is a stretch. I know it's a fraction. That fraction's value is bigger than 1, so it's a stretch. We're moving left 4 and down 6. So we have that. Doing the same thing, but focus on graphs. All right. So I got the parent function in black. I got another function in the blue and another function in red there. First, I want to describe what the function family is. The function family in this one, we should know it's a quadratic. All right, so we have that. So function family is a quadratic. Then describe the transformations. I said in this last slide, stretches and shrinks or compressions are fair game with these 3 functions. So the blue line, it looks more compressed than the parent function. It's getting wider, it's getting fatter. All right, so that means there is a compression. All right, so you can write compression. And it got shifted up 1. All right, you should be focusing on the vertex on each of these and seeing how those got shifted. So how did the vertex get shifted? Now this one, there's no stretch or compression on this one. It's just a normal graph. We're moving left or right, up and down. In this case, we're moving right 3. Right 3. And down 5. And that's our only shifts here. Got a couple more. We hopefully know with our notes in front of us that this is going to be a radical function. Radical, or more specifically, a square root function. We have that. Pick a reference point. Your reference point should be the vertex here. All right. I will not throw any stretches or shrinks with these. So the blue one went up 4 and right 2. So we went up 4, right 2. Transformations can be told to me in any order you want. Like in this one, I want left 3 and down 5. So we can switch up the order a little bit between the left, right, up, and down. So it's up to you. Whatever you see first. And there's our answers there. 2 more. We got an absolute value function. So in the blue one, we got a flip. We got a flip happening, and we moved right 6, and that was it. Last one, the red one, we no flip, no stretch, no compression. We went right 2 and up 6. That's all we got. Think you guys are getting the idea? Let's check out one more. This is a logarithmic function. Again, know the general shape of these. I'm not going to throw too many of these at you, and I'm not going to go anything too crazy with this. Find a point you can reference. It's 1, 0 here. Find that exact point up in the red one. Find that point in the blue one as well. So the blue one, all it did was shift right 4, and that was it. The red one, we moved, we moved right 3 on that one. See where we started. We started at 1, we shifted, that same point is now at 4. Same deal here, we shifted up 4, but we actually shifted right or left 2. So up 4 and left 2. And there's our transformation. Have the notes in front of you. You guys should be solid on these throughout.